Some trigonometrical applications of dot products. So let's take the first one, Pythagoras theorem. We want to use dot product to prove Pythagoras theorem. So there's no way we can talk about Pythagoras theorem without make reference to what? Right angle triangle. So let's have this right angle triangle. So this triangle is right angle because there is what? Angle 90 degrees here. So this is the longest side, which is hypotenuse. So what we want to prove here is the square of c square is equal to b square plus what? A square. How can we do that? So let's follow this the direction of the three arrows now. This AB is equal to what? AC plus what? BC. That is C is equal to B plus A. This C is equal to B plus A. And that is what we have here. Now let's try to square both sides. So C dot, because we are using dot product, we are going to use C dot C is equal to B plus A dot B plus A. Now let's try to open this brackets. So we have B dot B, which is this one. We have B dot A, which is this one. We have A dot B, which is this one. And we have A dot A, which is this one. So this A dot A as A square. This B dot B is equal to B square. That is modulus of B square. Now B dot A plus A dot B. B dot A is the same thing as A dot B. So we have two of them. So you have two A dot B. Is that clear? Because this one is the same thing as this one. Commutativity. So now A dot B, now we have two formulas for A dot B. Is either A dot B is equal to 0 or A dot B is equal to modulus of A, modulus of B, cos theta, where theta is the angle between A and B. So going by the first formula, which says what? A dot B is equal to 0. If we set A dot B to be equal to 0 here, a 0 plus a 0 multiplied by 2 will give you a 0. And then we're now left with c square is equal to a square plus b square, which is what? Pythagoras theorem. That is c square is equal to what? A square plus b square. So that is that. So we have used dot product to prove what? Pythagoras theorem. Now the second one, now let's use Pythagoras, let's use dot product to prove sine formula also. Sine formula. So sine formula, we want to prove that A over cos A is equal to B over cos C, which is equal to cos B, which is equal to C over cos C. Cos C, that is where we are going to. Now, looking at this triangle now. So if you follow this arrow now, AB plus BC is equal to AC. According to this arrow, AB plus BC is equal to what? AC is equal to AC. Now, moving forward, to make BC the subject of the formula, so we are going to write B minus C, because we say that C is equal to what? No, C plus A is equal to B. C plus BC is equal to what? B. So if you want to make BC the subject of formula, you need to transfer this to the left hand side so that you have B minus C. Therefore, this line BC is equal to B minus C, and that is what we have here. And then this AR is equal to what? R. So this AR is perpendicular to what? BC. So since this one is perpendicular to this, so the dot product, it must be equal to what? Is 0. That's why we're having R dot B minus C. So this line is equal to what? B minus C. This line, this BC is the same thing as B minus C, has been proven here, right? So R dot B minus C is equal to 0 because of the perpendicularity. Now let's open the bracket. R dot B minus R dot C is equal to 0. Therefore, modulus of R, so R dot B, I told you that R dot B may be equal to 0, or R dot B may be modulus of R, modulus of B cos Y. Because the angle between this R and this line is what? No, this R and B. We are talking about R and B. So the angle between them is Y. Is that clear? So modulus of R, modulus of B cos Y, minus RC, R and C. Now we are going to have modulus of R, modulus of C cos X this time around, then is equal to 0. Then since this line is not equal to 0, Therefore, b cos y minus c cos x must be equal to a 0. Is that clear? Because that one is not equal to 0. Therefore, if you transfer minus to this side, you will get plus. So you now have b cos y is equal to c cos x. Now, if you divide both sides by cos x cos y, so here now cos y will cancel cos y, we have b over cos x by the left hand side. Then by the right hand side, divided by cos x cos y, cos x will cancel cos s, you are going to have c over cos y. So and that is the next line now. So having said that, so let's call this one equation 1 now. So we have b over cos s, c over cos y is equal to equation 1. Now let's now come back to this diagram now. Looking at the triangle abr now is a triangle. So we have 90 degrees here. So the sum of angles in a triangle is equal to 180 degrees. And we have 90 here, meaning that the sum of x and this angle b must be equal to 90 degrees. That's why we're having s plus b is equal to 90 degrees. It implies x is equal to, you transfer b to the right hand side, we have 90 minus b. Also, when you look at angle ACR, here is also 90 degrees. So the addition of y and angle c must be equal to 90 degrees also. So if y plus c is equal to 90 degrees, then it implies that y is equal to 90 minus c. Now substituting the values of x and y into equation 1. So anywhere you see x, you write 90 minus b. Anywhere you see y, you write 90 minus c. So this one will now become what? B over 90 minus b minus c over cos c. Now to open this bracket now, let's use this formula now. This is the triangle trigonometric angles now. So to open now, cos a minus cos b is the same thing as cos a cos b plus sin a sin b. Is that clear? So our a here is 90 and our b is b. So to open this one, we are going to have cos 90 cos b plus sin 90 sin b. So cos 90 cos b, cos 90 is equal to 0 multiplied by cos b, that one will be 0. Then sin 90 sin b, sin 90 is equal to 1, then 1 multiplied by sin b. That's why we are having only sin b here. Now coming to cos 90 minus c, also it will be cos 90 cos c plus sin 90 sin c. So cos 90 is equal to 0, 0 multiplied by cos c will give you 0, then plus sin 90 is equal to 1 multiplied by sin c. That's why we're having only sin c here. And this is what we call what? Sine formula. We have modulus of b over sin b, then modulus of c over sin c. Is that clear? So that is how to use dot product to prove sine formula. Then the last one, which is cosine formula. We can use dot products to prove cosine formula also. And let's look at how it will go now. So this is cosine formula. So let's look at this triangle now. We have A, B, C here. So looking at this direction now, AB plus BC is equal to AC, meaning that C is equal to A plus B. So if you make A the subject of formula, is that okay? You are going to have B, A is equal to B minus C, and that is what we have here. Don't forget I said that AB, which is equal to C plus what? A is equal to B, is equal to B. C plus A is equal to this B. Is that okay? So if you want to make A the subject of a formula, you are going to have A is equal to B minus C, and this is it. So if you square both sides, so we have A dot A is equal to, open this bracket, B times B, this is B dot B, B times C minus C dot B minus B dot C, then minus times minus will give you plus, plus C dot C. Now A multiplied by A is equal to A square, modulus of A square. This one is B square. This is minus, right? Minus 2BC. Then this is plus what? 2 plus C square, modulus of C square. Is that clear? Now don't forget that I told you that B dot C may be equal to 0 or modulus of B modulus of C. Then angle in between what? B and C. Is that clear? So this is B, this is C. The angle between them was what? A. Is that clear? So that is why we are having modulus of B, modulus of C, cos A. And this is what? Cosine formula. Similarly, we can have B square is equal to A square plus C square minus 2AC, then cos B this time around. Similarly, we can also have C square is equal to A square plus B square minus 2AB cos what? Cos C. And that is the what? How to use dot product to prove cosine formula.